To start this, what we'll do is we'll write this given expression as z square mod z bar square plus 1 by z square. So notice this becomes z square, because z square times z bar square is mod z to the power 4. And now we'll write this as mod z to the power of 4 plus 1 times conjugate of z square by multiplying the numerator and denominator with this. So the given expression simply becomes this. Now notice that replacing z bar by z, nothing will change, because at the end we are asked for the possible values of mod z. So to proceed further, we'll just ignore this. So this is not equals to this though, but we can just analyze this. So we have 1 plus 1 upon 4 into mod square equals to a plus iota b. So if z is p plus iota q, we have 1 plus 1 upon p square plus q square whole square into p square minus q square equals to a, and 2pq plus 1 upon p square plus q square whole square equals to b, and both of these are integers. Now what we'll do is squaring both these and adding them, we'll get 1 plus 1 upon mod z to the power of 4 squared plus and then we'll get p square minus q square whole square plus 4p square q square. So notice this thing becomes p square plus q square whole square or we can write this as mod z to the power 4. So we get 1 plus 1 upon mod z to the power of 4 squared times mod z to the power of 4 square plus b square for some integers a and b. So this thing becomes mod z to the power of 4 plus 1 upon mod z to the power of 4 plus 2 equals to a square plus b square. So this is the relation that mod z must satisfy for if z follows this satisfies this condition, that this is a plus iota b of the form a plus iota b. So we have mod z to the power of 4 plus 2 now the only thing we can do is to check each and every values which we are given. So plugging in mod z equals to 43 or another 5 plus 3 root 205 gives us 1 upon mod z to the power 4 is 1 by 2 into 43 minus 3 root 205 upon 43 squared. So 43 squared is 3 into 43 is 43 into 40 is 1720 plus 129 1849, and this becomes 1845. So this minus this is 4. This is 2 times this is 4, which becomes this by 2. So z plus this becomes 43 plus 2 becomes 45. So this whole thing is 45 for option A. And is this equals to a square plus b square for some integers? Yes, when a is 6, b is 3, this is true. So A option is possible. Similarly, we'll have to check all the 4 options. So A is the answer. What else? So if we have mod z to the power of 4 equals to 7 plus root 33 4, we'll get 1 by mod z to the power of 4 is 4 into 7 minus root 33, which becomes this. So this plus this becomes 7 by 2, and that plus 2. So clearly that won't satisfy, because it won't be a integer, and a square plus b square is an integer. So B is not correct. Then C, we have mod z to the power 4 is 9 plus root 65 by 4. That gives us 1 upon mod z to the power of 4 is 4. 9 minus root 65 by 81 minus is 16. This becomes this. Adding them, we'll again get 9 by 2. So that won't be correct either, because 9 by 2 plus 2 is not an integer, and a square plus b square is an integer. Then finally, mod z to the power of 4 is 7 plus root 13 by 6, which gives us mod z to the power of 4. The reciprocal of this is 6 to 7 minus root 13 upon 49 minus it is 36. So this, adding them, we'll get 14 by 6, which is 7 by 3. And again adding 2 to this will be 15 by 3. It is not possible. So the answer is A.